C.7, the last two questions for this test. Question number 23 and number 25. Now, first, question number 23, we did a similar question in this video. Video M4F1, question number 13. And this one, very close to that one. So basically, you can just use the same idea, but you need to modify a little bit in a critical step. The main difference is the sign here. Here, I give you n minus 5. And in that question, we did n plus 5 to the fourth belongs to big theta of n to the fourth. Yeah. All right. So here, the main difference from plus sign to minus sign. How do we bridge the difference, right? The method basically the same, but we need to take care of that important difference, to bridge the gap. All right. So when we start, we try to use the same idea as this example. So when we start, we like to find two constant. C1 times n less than or equal to n minus 5 less than or equal to C2n. How about that? Okay, you need to determine two positive constant. Make sure two positive constants. C1 and C2. Yeah. But here, look at this. Positive constants. I didn't say positive integer constants, right? Not necessarily integer. We do not require it to be integer. All right. So here for this part, easy. Yeah. C2 part, easy. I think you can get it easily. But how about the C1 part? Can you imagine for certain constant C1, you put there, you can find that inequality. Yeah. So C1 could be a fraction. A fraction number is fine. Yeah. You're allowed to use a fraction number. All right. Then for the inequality, after you put certain fraction number, the inequality is true for n greater or equal to certain integer and 0. You have freedom to choose this one. Not necessary for all non-negative integers. Remember the role of this n0. The role is important. Yeah. Because when you put a certain fraction there, then this n0 is important to make. All right, yeah. So here, yeah. When you choose certain fraction C1, in order to make the inequality hold, choosing appropriate n0 is important. All right? Yeah. Choosing certain n0 is important. You can find it easily. After you get that, then remaining routine work, yeah, so you can complete it. All right, yeah. Finally, our last question, question number 25. 5-element array, this time 5-element array, but we know important information. The first 3 elements already ordered, x1 less than x2 less than x3. This information is useful. Do not waste it. All right. How many comparisons do we need to sort this array for the worst case? Yeah. Here, yeah, the hint, yeah, we used that before. Video M4 C4. In that one, we sort. That is in that video, we sort 4-element array. Yeah, the difference, just the one. Here 5-element, that place 4-element, but we have some extra condition. We should take advantage of it. Yeah. Here the main thing is, I like you to connect it to the insertion sort. Insertion sort. Yeah. Because if you go back to look at this video, how to sort 4-element array, we connect to insertion sort. We connect to the insertion sort. Yeah. Here you can see it is some kind of extended insertion sort situation. Here the situation we have. First, we have a sorted array in ascending order. Yeah. But now we want to insert 2 elements, x4 and x5. Not 1, 2. Yeah. Can you insert one by one to get the best solution? Right? Yeah. Try that. Yeah. Insert one and another one. Right? But look at the worst case, not the best case. Yeah. But when you do the insertion, another key point, you really need to use binary search. Type insertion. Not our sequential search type insertion. All right, that's critical. So not the sequential type insertion. All right, now let me just write is type insertion. That can save you a little small number of comparisons. Save one is important for us. All right, yeah. All right, so do your best. Yeah, try your best. After you have all this kind of related information, yeah, if you understand the examples we already have in those problem-solving videos, then you should do, pretty good job in this test. All right, so let us finish all the hints for part C.